Welcome to another edition of Math with Mr. Douglas. Yes, we are looking at special situations. You are going to learn some tricks, math tricks from the Math Jedi. Here we go.
Okay, so we are going to get into some here we go. We're going to get into some awesome special multiplying situations. So special multiplying polynomials. I'll call it tricks. Why not? Who doesn't like a trick, right? Yeah, for sure. Let's start off with a pretty cool example to get you kind of going. So if I asked you to go and multiply right now 42 times 38, right? You're walking down the road, you're like, hey, what's 42 times 38? What can I do? Okay, so first off, that's hard. Let's try to make it a little bit easier right now. So I'm going to ask you to think of a number right now, the same number that I can add or subtract from both of these numbers individually that will make them the same. Make sense? So, okay, so think of a number. Think of a number to add or subtract that will make it equal. There's probably a better way to say it. When you see the example, you're like, oh, I get it. Okay, so looking at these numbers, you're thinking like, what is a number that's pretty close to both of these? Well, I'm hoping you're thinking like, oh my gosh, it's 40. Okay, so we want to take a look at what number could I get these to be very similar. And I'm hoping you're looking at something like, how about 40? Like, how do we make these become 40? Because that would be neat. I don't want to change the value, but I want to change it to getting there. So if I wanted to make this become 40 and this become 40, because that's going to be fun, right? What is 42 if I was using 40? It would be 40 plus 2. Is 40 plus 2 still 42? It absolutely is. And what would this be if I wanted to make this use of 40, but still be 38? I'd have to go and subtract 2. Is that still 38? It is. So these are the same now, aren't they? Yeah? But I'm using 40s. Now 40s are going to be pretty cool because I'm going to teach you a really cool trick here. And this trick is called the difference of two squares. I'm going to write it in green. And basically, if you remember back to our lesson on FOIL, or if you just learned about FOIL, you know about first, outside, inside, last. Well, I'm going to do something really cool for you. If you notice that your terms in here, your little terms here, they're actually just one term, but if you realize the numbers are exactly the same, except for your plus and your minus, right? You can use something called the difference of two squares. And this is what you can do. You could do this. You could do 40 squared, because there's two of them, and you can go and subtract, that's why it's called the difference of two squares, the second one squared. You can go and do that. So this will become way easier. So 40 squared, hopefully you can just do that like, oh, it's 1600, and then minus 4. So your answer is 1596. Boom, just like that. Couple things here I want to highlight. One is just being able to play with numbers a little bit and try to have some fun. And this idea of the difference of two squares is going to be coming up. And the difference of two squares, what it really means is the difference, which means subtract. And you have to have two squares, because it's the difference of two squares. It's not the difference of like a pineapple. It's the difference of two squares. Here is one square, and here is the other square. So it is the difference of two squares. Pretty cool, right? Yeah? Let's go see another example. Because if I was a kid, I'd be like, what are you doing? Okay, well, let's go and do another one. I'm going to use some of the same numbers just to kind of make a point. Okay, so 42, that 42 is coming up a lot. Oh, why not? Times 58. So now for this one, you've been thinking like, oh, how can I get to a closer number now? What number do I want to get to? That's the hard part. So the hard part is saying like, oh, I want to get to 50. because I can see these both get to 50 in very similar ways. So if I wanted to do that, I could do 50 and still just minus 8. Oops, there we go. Minus 8. That's still going to give me 42. And for the other one, I'm going to go 50. I'm going to add 8, because if we go 50 plus 8, there we go, that's still going to get me 58. Does that make sense? Yes, great. Now I'm going to do that really cool difference of two squares thing. So this is kind of building on FOIL, but I can do this. I can say that basically 50 squared, and I can subtract the other one, 8 squared, like that. So 50 squared, so I'm hoping you're saying like, oh, okay, that's like 2,500. And hopefully you can do this one, minus, whoops, 64. Now that's a lot easier to do, isn't it? And you're going to get what, like 2436, I think, 2436. And you can kind of get it like that. So hopefully that's getting a little just a little like math number tricks and that kind of stuff. And we're going to kind of build on this idea. And we're going to do some squaring of binomials. That's what we're going to be doing. So let me get rid of that. Let me get a fresh screen. Oops. Oops, there we go. Oh. So there are two main patterns that I want to be showing you. The first pattern is when you square a binomial. So that is where you're going to be kind of multiplying two binomials together that are the same. So the classic kind of example is if you had x plus y and you went and squared it. So remember, x plus y squared, what that really is x plus y times x plus y. Cool. So you got to kind of know that pattern. And basically how it kind of works is you could go and do your FOIL with this, right? Once you kind of show that, you can go and do FOIL. But if you can memorize this pattern, it helps a lot. So you basically have to square that first term. So you have to square the first term. You have to double the product of those two things together. And then you have to square the last term. That's what you need to do. So it ends up looking like x squared plus 2xy plus y squared. Now, it's always easier to see this when you actually have numbers. So let's just, I don't know, let's have d plus 4? Sure. So d plus 4 squared, right? So what am I doing this one now? I'm going to go slow. So I'm going to square the first term. That's going to be d squared. I'm going to write that. I'm going to double the multiplication of these d times 4, which is going to be 4d, right? And then I'm going to add the square of the last term. That's the pattern. And eventually you'll memorize this pretty easy. So I'm going to double this. So it's going to become 8d. So 8d, and I'm going to square that to 16. Okay, so that's the first one. So squaring it that way. Realize that this is the addition. But what happens when it's a negative? I'm glad you asked. Well, what happens if it is x minus y all squared? And again, what this would really mean is x minus y times x minus y. And you could go and do the FOIL like you've seen in other videos or hear me talk about, or you can go and just memorize this. So basically, you square the first term, so far so good, and you subtract the double of x times y. Let's see, can I still use this video? Even though it says, hello, Mr. Douglas, I was what? Oh, somebody was wondering something. This is what happens when you start to, close that, there we go. When you are doing a video during the day, and you have a student saying, hey, I was wondering. Okay, that's gonna stay there forever, because you know what? I'm not gonna re-edit this. Okay, and then you need to go and, actually, you're gonna go and add the square of the last term too. So I'm gonna go and add the square. No y squared. That's the only part where kids go wrong. So you end up getting x squared minus 2xy plus y squared. The only difference from the last thing you just saw is that. That's the only one. Let's see an example. Let's choose a nice pink example. Let's do 4x minus 5 squared. Okay, that's cool. So I'm going to square that first term. So let's go nice and slow. I'm going to square that first term. I'm going to subtract the double of the multiplication of these. So this is maybe where you might find it a little bit challenging. This is 4x times just 5. And I'm still going to add the square of the last term. So I'm going to add, but it doesn't work. I really need to close all of this. Okay, well, this student is having a little bit of problems. That's okay. The student will get some answers soon. There we go. But I got to finish this video first. Okay, so let's go and do this. So let's get 16x squared, and let's go and do this. This is like 20x. This is minus 40x. I'm going to square that last one, so it's going to be plus 25. Okay. So that's the first thing of basically squaring a binomial. So that's a pretty cool pattern, right? I can hear everybody going like, yes, that's awesome. Cool. Now there's going to be a sum and difference pattern I'm going to show you as well. So a little bit of a different one. Let's see if that student comes back. Yep, here we go. So x minus y is 12,000. I wonder what he's talking about. So this student is obviously making some kind of equation. I really need to get all my notifications off right now. But I'm going to power through. Hopefully you're all going like, oh, this is kind of fun. So what do I want to show? The sum and difference pattern. So sum and difference. So this sum and difference pattern, difference of two squares. You also hear this kind of talked about. And let's just dive into it. So this is basically where you are going to have something very, very similar. You're going to have two terms, not terms, two numbers, variables, that are basically being multiplied together that have the different signs. So a plus b and a minus b. It's the same numbers here, but you're going to add and subtract. Okay. So when you see that, you get this really cool pattern. It's going to be called a squared minus b squared. Okay, and we're going to call this the difference of two squares. Okay, so this is also known as the difference of two squares. Difference of two squares. Difference means subtract, and obviously two squares is when you square two things, right? So see, everything's squared, and this is the difference. Okay, so this is something that you're going to start to recognize, I'm hoping, when you start to see things. So let's say you had, let's do an example, x plus 4 times x minus 4. So same thing, but you guys notice that like, hey, wait a second, something's going on here. A plus and a minus. So how does this work? Well, basically you end up squaring. So this one, you square the first term. So I would square the first. I'm going to square that. Oops. And I'm going to subtract the square of the second. Does that make sense? So it ends up being x squared minus 16. Like that. That's pretty neat, isn't it? Yes. It is, it is. Shall I do another example? Okay, let's get a nice, maybe a little bit more interesting red. Let's do 2x plus y. That's a really hot pink, isn't it? 2x minus y. So you're noticing that this is going to be the difference of two squares. So I'm going to square that very first thing. So I'm going to go and do that. So if kids are going to find this a little bit harder, you can do that. And I'm going to subtract the square of the last one, which is a little bit easier. So I'm going to square that. So it becomes 4x squared minus y squared. Kind of like that. How does that look? It's not too bad, right? Not too bad at all. Okay, so that gives you some different kinds of patternings of showing how things kind of work. And hopefully that'll get you going in terms of multiplying binomials. Lots of different ways if you remember those patterns. Otherwise, you can always use FOIL. It is tried and true. Have a good day. Hopefully that student has figured things out. I'm gonna go help the student now.
Thanks everybody for tuning in for another edition. Until next time, go subscribe, tell your friends, get my subscribers up past, I don't know, 100, 200, 300, maybe even 1,000. Until next time, thanks so much. Have a good day.